So on that sheet, there's a list. So we'll just start with the first one, sine of 2 pi over 3. Okay, so what we want to do is know the answer to this. What is sine of 2 pi over 3 equal to? And basically what that means is, if you were to look at the graph of sine, what is the y value of the point at 2 pi over 3? So it's just asking for a value, just like saying what's the square root of 4, and the answer is 2. It's asking for the answer to this. Okay. So the steps are these. You draw the angle. So step 1, draw the angle. Step 2, find the reference angle. Step 3, find the sine using the cast rule. And step 4, the answer from the memorized values from that table. So 1, 2, 3, 4, it sounds like a lot of work to find one value, but it's really not. Okay. So step 1 is to draw the angle. So we're going to draw 2 pi over 3. So to draw 2 pi over 3, remember you take your pi and cut it into how many pieces? 3. So 1, 2, 3. Those are our 3 pieces. How many of those pieces do we want? 2. This is our start. So we go 1, 2, and the line would be here. 2 pi over 3. So that's step 1, draw the angle. Step 2 is the reference angle. So what is the reference angle? Remember, the reference angle is the angle between the x-axis and that line we draw. So how big is this piece right in here? It's 1 pi over 3. Just one piece of the pi. Okay, that's step 2. Step 3 is the cast rule. So which quadrant does it land in? Just circle the letter. So it landed in here. What does the S mean again? Sine is positive. So are we looking for sine? Yes. So that just means that the answer is positive. Step 4 is to write the answer down. So sine of 2 pi over 3 is equal to positive, because sine is positive in that quadrant. And you look up on the table pi over 3 for sine, which is root 3 over 2, and that's it. So you can kind of do all of this in one step. Let's write the next one down. Cos of 2 pi over 3. So when we look it up, cos of pi over, or sine, we were looking up sine of pi over 3, that was root 3 over 2. So you look under the sine, pi over 3, you've got your table all drawn, and that would be your answer. Okay, so cos 2 pi over 3, it's the same angle, so it's the same thing to draw. What's the only difference? So it's here, the reference angle is pi over 3. The cast rule is sine, which means this answer, this is not a sine we're asking for. So since sine is positive, what's cos there? Negative. And we need to look up cos of pi over 3 on the table, which is 1/2. So the answer is negative 1/2. So I did it all smaller here. I didn't write out the steps. We drew the angle, which we already had drawn, so I didn't really draw it again. I put the cast rule right on the picture, and I also wrote the reference angle right in the picture. So you can do it all in one little step. So that's your showing your work, and your answer is here. So why was it negative? Because it wasn't in the C or the A. All are positive if it lands in the A, so it doesn't matter which one we ask for, they'd just be positive. The only one that's positive if it lands in this quadrant is sine, the rest you would put a negative. Okay, and so on. So, number 3. Tan of 2 pi over 3. So again, same angle. Reference angle is pi over 3. That's the same because it's the same thing. The difference is the cast rule and the value that you look up in the table. So C-A-S-T still lands in S, so this one is negative because it didn't land in the T. Okay. And what's tan of pi over 3? Yeah, if you look in your table, it's tan of pi over 3 is root 3, so negative root 3. Okay, questions? Okay, so let's go to a new angle. 4 says cos of 7 pi over 6. So we have to draw a new angle for this one. 7 pi over 6. So draw your pi. Is it more than 1 pi? It is, because how many pieces will the first pi have? Cut into 6 pieces. 1, 2, 3, 4, 5, 6. We need one more piece, so we have to go down here. 7. So 1, 2, 3, 4, 5, 6, 7 right here. So 7 pi over 6. The reference angle is where? It's between that line and the x-axis right here. That's the reference angle. How big is that piece? So when you label the angle itself, you label it here at the end of that terminal arm, the line. Here's your start, and that's why I started counting that way. But the reference angle is in here, and how big is that? One piece, pi over 6. It's just what the size of that angle is, just pi over 6. So we're going to look up cos of pi over 6 to get our answer, but the cast rule will tell us whether it's positive or negative there. So we're in the T quadrant, so what would cos be? Negative. Negative. Look up cos of pi over 6, which is root 3 over 2. And that's our answer, negative root 3 over 2. And we didn't practice drawing a lot of these ones. This next one is sine of 4 pi. This one lands right on one of the axes, so you don't do the reference angle part. It's actually a bit easier. You don't need to worry about the cast rule or the reference angle if it lies on an axis. So here, if we were to draw this, what's 1 pi? This is 1 pi. So here's our start. Here's 1 pi to here. Where's 2 pi's? Back to the start. Where's 3 pi's? Pile another one on top of it, so we go one more. That's 3 pi, and then 4. Back to the start. So it ends here. This is 4 pi. Now on your original circle, what line is that? Or 2 pi or 0. They're the same values. Look at the table. Look at 0 and 2 pi. Are they the same for sine? Both 0, 1, it's the same for sine. You don't even need 2 pi on there because they're the same. It's back to the start. And cos, they're always the same because you're back to the same spot. So it's always the same spot as the same answer. So you could look up 0 or 2 pi for that spot. If you land on the axis, you just look in the table. It tells you the answer. So we want to know what sine of 0 is, or sine of 2 pi, that's the same, and sine of 4 pi is all the same because they land all on the same line. So you can look up 0 or 2 pi, which is what? What's sine of 0? 0, that's the answer. So you should write a little note. If it lands on an axis, you just look up that axis. They're all here. 0, pi over 2, pi, 3 pi over 2, or 2 pi. They just, whatever one you land on, you look up. Okay? So that would just be a little note that you don't need to do the reference angle, you don't need to do the cast rule, you just look it up. That's it. So 6. Tan of negative pi over 3. So what's the negative mean?
Go down.
Right, we go backwards. So we go down instead of up when we find our angle. So here's our start, but the negative means go in this direction. If it's positive, we go up to start, but that's a negative angle. So it doesn't mean anything other than, here's your first pi, split it into 3 pieces, and we want only 1. So here is negative pi over 3. Now you don't look up negative pi over 3, you look up your reference angle. How big is this piece right in here? Pi over 3. It's not negative pi over 3 big. You're looking up the size of it. The size of that piece of pi is 1/3 pi over 3. So you just look up tan of pi over 3 in our table, which gives tan of pi over 3 is √3. Well, now what else? That's not the answer necessarily. We need to know if it's positive or negative before we write it down. So the cast rule, it's in C, so tan is, it's not cos, so tan is negative, and the answer is √3. So this is your reference angle, that gives the number answer, and the cast rule gives the sign, whether it's plus or minus. Seven says tan of negative 7 pi over 4. So, draw it. Negative, so we're going to go backwards. How many pieces is the pi cut into? 4. 1, 2, 3, 4. We need more. Cut the next one into 4, so 5, 6, 7. That's enough. So right here is negative 7 pi over 4. What's the reference angle? It's the line between that line and the x-axis. It's always one piece as long as that was reduced. So this is how big? Pi over 4. So we want to look up tan of pi over 4. I think that's 1 on our table. And the cast rule says what? We're in the A. What does A mean? All are positive. So it's just positive if you land in there. Positive 1. And you don't need to write the plus if it's positive, but I always do because it's always something you're looking for. Is it positive or is it negative? So I usually put the plus, but it's not wrong if you just said 1. Okay. All right, what about cotan? How would you do this? Cotan of 2 pi over 3. So only sine, cos, and tan are in the table. So what do we do? How do we do one of the other 3 that aren't in the table? What's it the reciprocal of? What do we flip over to get cotan? Tan. So we look up, we find the answer to tan. So whatever that answer is, and then we flip it over. I'll put reciprocal, that's the right word. Inverse, remember, is not the right word. It's not the inverse. It's the reciprocal, flipping it over. Inverse trig is something else, and you do those in 1003. Okay, so we're going to do tan of 2 pi over 3. We already did it, but we'll do it again. 2 pi over 3 is cutting your pi into 3 pieces. 1, 2. 2 pi over 3. The reference angle is pi over 3. So we look up tan of pi over 3. And then the cast rule says that it's negative. Tan of pi over 3 is root 3. So this is negative root 3. So what would cotan be? This is like a root 3 over 1. If you want to flip it over, yeah, and still negative. The sign's always the same. So negative 1 over root 3. When you flip over, it stays the same sign. It's still negative. And remember, we don't usually write negative signs on the bottom of a fraction. It's either in front or on the top, but it means the same thing. Okay. Okay, so what about the next one? Sine of 2 pi over 4. So I actually wanted you to notice that you could reduce it, but if you didn't notice that, let's draw it pretending we didn't notice that it can be reduced. What can it be reduced to? The 2 cancels, so it would be pi over 2. Okay, but let's pretend we didn't notice that. So if we went to draw this, we would cut the pi into 4 pieces. And we want 2 of them, so that lands here. We don't look up the reference angle. Why not? Because it's on an axis. And when it's on an axis, you just look up that axis. You don't worry about the sign, because that's already in the table. So what axis does this land on? Pi over 2. So you just look up. This is the same as sine of pi over 2. Whether you noticed it reduced or not, it's still the same thing because we landed on that axis. And what is sine of pi over 2? 1. And that's just looking it up in the table. Okay, 10. Cos of 11 pi over 4. I want you to try to draw that. See if you can get it in the right spot. So try to draw it. Try to get the answer. I'll give you 30 seconds. All right, who's got an answer? Okay, a couple people. So 11 pi over 4. So there's 4 pieces. What would it be all the way back to the start? 8. And how many more do we need? 9, 10, 11. So it lands here. So our reference angle is in here, which is pi over 4. So we look up cos of pi over 4. 1 over root 2. Cast rule says it's in the S, which is negative for cos. 1 over root 2. Okay, if you know your values, you have your table to look at. It really is less than a 30-second question. Okay, you should be able to draw them. Now, what about this one? What's the problem here? pi over 10 is not in our table. So we must be able to reduce it. So what's 5 pi over 10? Yep, pi over 2. The 5's cancel. Tan of pi over 2 is just in our table. We don't even need to draw it if you notice that. So what's tan of pi over 2? Undefined. It's an asymptote on the graph. Just out of curiosity, so I'm going to add this in. It's not on the sheet, but what if we had cotan of pi over 2? It's not undefined. Yeah, so remember when we made up the table, so here is, to get tan of pi over 2, I said 1 divided by 0 is undefined. Cotan, so this is 1 over 0. What's the reciprocal of 1 over 0? 0 over 1. What's 0 over 1? That's okay. That's 0, right. So cotan of pi over 2 is actually 0. Okay, they're the opposite of each other. It's either 0 or undefined. So if tan is undefined, then the cotan is 0. And what if tan was 0? So what if I wanted, say, tan of pi? What's tan of pi? Tan of pi is 0. So cotan of pi, undefined, because it would be flipping over 0. It puts a 0 on the bottom, which is undefined. Okay, so those are what's reciprocal of each other. All right, 12. Cosecant of negative 7 pi over 6. So negative goes backwards, but what are we finding? Because cosecant's not on our table. What's it the reciprocal of? We want to find, do you remember? Remember I said it's the opposite letter? Sine. So sine of negative 7 pi over 6. We're going to find that and then flip it. Okay, so negative 7 pi over 6. We're going backwards because it's negative. Pi over 6 cuts your pi into 6 pieces. 1, 2, 3, 4, 5, 6. One more. 7. Negative 7 pi over 6. Our reference angle's in here. It's one piece, so pi over 6. So we want to look up sine of pi over 6. That's 1/2. Cast rule. Is sine positive or negative there? Positive, so positive 1/2. What would that be flipped over? Still positive. 2 over 1 or just 2? Okay, same sign, but flip it over. So you draw your angle, look up the reference angle, and figure out the sine. That's your step. So for secant, what do we find first? Cos. So cos of, so we need to find cos of minus 4 pi over 3, and then whatever the answer is, we're going to flip it to get this. So we're going pi over 3, so cutting into 3 pieces. And we're going backwards, so 1, 2, 3, one more, minus 4 pi over 3. Reference angle. We're figuring out cos. The reference angle's in here, one piece, pi over 3. And I said before, and you may be noticing, it's always the number on the bottom. Like if this was a pi over 3, it's always pi over 3. The only time it's not is if that fraction wasn't reduced. Initially, you'd reduce it, and then it's whatever number's on the bottom. Okay, so pi over 3 for cos is 1/2. Is it positive or negative in that quadrant? Negative. So negative 1/2. Flipped over, that would be negative 2. Over 1, which is negative 2. Tan of 5 pi. And 15 is cotan of 5 pi. So, they're just a reciprocal of each other. One of them's 0 and one of them's undefined. So what do we look up, I wonder? So tan of 5 pi. So where would that be? 1 pi, 2 pi, 3, 4, back to the start, or back to here, 5. So here is 5 pi. What line does that land on that we would look up? Because that's an axis, pi. So this will be the same as tan pi, which is 0. So this one is undefined. Remember, when we flip over 0, it's undefined. That puts the 0 on the bottom. So, secant of negative 4 pi. Draw it. That one's going backwards. Negative 4 pi. And then the last one, 17. So negative 4 pi. So negative 1 pi, 2, 3, 4. Back to the start. What do we look up? 0 or 2 pi. But that's secant. We can't look that one up. What do we look up? Cos. So we look up cos of 0 is 1. What's 1 flipped over? 1. Yeah, still 1. But 0 flipped over is undefined. 1 flipped over is 1. Undefined flipped over? 0. All right, what about this one? Where do we land? Last one. Pi over 2. So that's a pi cut into 2. So that cuts it there. 1, 2. We want 7. 3, 4, 5, 6, 7. What do we look up? This is 0, pi over 2, pi, 3 pi over 2. So look up sine. This is the same as sine of 3 pi over 2. And if it lands on an axis, you don't worry if it's plus or minus, because that's in there already. What's sine of 3 pi over 2? In the table. Negative 1. Okay, so that's how you do your values. So there'll be a list of those. They're like less than 30-second each. But if you don't have your table memorized, that's like a whole bunch of marks you don't get. Does that make sense? Yeah. Just quick. Draw your little picture, and you know because you've got your table written down on the back of your test. So you flip it over, look up the value, write it down, make sure you put plus or minus. Just a real quick question worth 1 mark each, but that's like 10 marks you can't get if you don't know them. So be careful of that. Okay, so what I said I would do at the end of class is write down the identities you need to memorize. And then on Wednesday, we'll show you how you need to use them for the test. So, identities. So we already have a few of these that we know. These are actually called the reciprocal identities, and that's not that you need to know the name of them, but each set of identities has a name. These are called the reciprocal identities. Which also means that, like, if you have cos, you can write that as 1 over secant. They're the reciprocal of each other. Does that make sense? So you can write them either way, and it's the same thing. They mean the same thing. Okay, those are the reciprocal ones, so you do need to know those. There's 4. The next are the odd even. Which says that sine of minus an angle is equal to a negative. So if there's a negative in there, the answer is negative. Which you could go back and look. If you do a sine of any negative angle, the answer is actually negative. Okay. And cos is positive. Oops. Cos of a negative angle is positive. Tan is the same as sine. Okay, so those are helpful sometimes, not necessarily with what we're going to do with the identities, but you'll need them for 1003. So I'll just tell you the ones that you need to know for that course. In here, they're useful. You could be asked about them. But the next are the Pythagorean identities. Sine squared plus cos squared equals 1, and 1 plus tan squared equals secant squared, and 1 plus cotan squared equals cosecant squared. So there's 3 of those. Now the first one I just memorized, sine squared plus cos squared equals 1. The second one, 1 plus tan, there's like the T looks like a plus sign. So remember that tan and secant go together in that one, and the plus is in front of the tan. The secant's on the other side. This is actually the same. If you know this one, cotan, secant, cosecant, so you can replace them.